Okay, so now finally we got the limit as h goes to 0 of some horrendous thing, and it's you're told that it equals f prime of c for some function f and for some c. What is f prime of c? So before we learned the power rule and we just had limits, if you were actually expected to evaluate this, it would be really tough algebraically to do so. Really tough. We didn't specifically cover a method for it because RatCon doesn't quite work here. But it would be a combination of lick 'em, overlook 'em, and some type of RatCon. So once you're told that this does represent the derivative of some function, just think about this part first. If I can identify the function and the x value, then that's a good place to start. So h going to 0, this is what I called the modified form. And remember, modified form, MF for short, right? It's going to be f prime of c is the limit as h goes to 0, bless you, of f of c plus h minus f of c all over h, right? This is really all you need to identify the function. Because in general, if you say, I don't like you, c plus h, you're staring now at f of x. And then if you peek underneath there, you can see the c value. All right. So if we do that, let's come up here. I don't like you 1 plus h. That means our function is going to be -5 over the 4th root of x to the 7th. And then if we peek underneath there, what's the c value? Peek underneath there and you get c equals 1. So that second term is not part of the function. That second term must be f of c, which must be our function evaluated at 1. And is it, if you identify it? Yeah. And it's kept in its, unsimplified form. So now we can kind of restate the question. Okay, let's restate the question in something that's easier to work with. Get rid of this. We don't need that page number. Now that we've identified the function, let's just say if f of x equals -5 over the 4th root of x to the 7th, number 1, what is f prime of x? And then number 2, what's f prime of 1? Okay. Well, how am I going to find f prime of x? I can use the power rule, yes? So if I can write it in the form ax to the nth power, I can multiply and subtract. So to do that, I'm going to have -5, and I'm going to bring that 4th root of x to the 7th from the bottom to the top, and it becomes to the -7/4. So you'll get really adept with fractional exponents, right? It's 7/4 in the denominator. Bring it to the top, it becomes negative. Is that now in ax to the nth format? Yep, it is. So now I could say, all right, the derivative of the left is f prime, and the derivative of the right is multiply and subtract. So remember, that's like -5 over 1. So you multiply straight across. -7 times -5 is positive 35. 4 times 1 is 4. So there's my new coefficient times x to the subtract 1. -7/4 minus 1, -11/4. Okay, now that technically is the derivative. If we want to use it, it's worth simplifying it. Let's get in the habit of putting it back into the original form without negative exponents or fractional exponents. That's 35 over 4, and then it becomes the 4th root of x to the 11th. So there's the pretty version of it. Now that I have the derivative function, I can use it in one of two ways. I can either plug in an x to find the slope of the tangent line to that graph at that point, or I can even set it equal to a desired slope and solve for x to see where it's equal to that. I want to find f prime of 1. So here we go. F prime of 1 is going to be 35 over 4 times the 4th root of 1 to the 11th power. Well, 1 to the 11th power is 1. The 4th root of 1 is 1. 1 times anything is itself. So the answer is 35/4. These are the only two ways on a test, I will expect you to use the modified or the alternate form, same as College Board. I'm not going to have you on a test set up an alternate form, set up a modified form to evaluate something. We practice that way because it's kind of fun, but you're going to have to either be told it's the derivative and given the limit, and then deconstruct it to identify the function and the C value, okay? Identify the function and the C value, and or to actually evaluate it by recognizing the function, taking its derivative using a different rule like we did here, and then evaluating by plugging in the C value, okay?
So we will only be deconstructing those?
On the test tomorrow and on the AP exam, you'll only be deconstructing, right? Yeah. Okay. Any questions on that one? Fantabulous, right? Now, if you were on your way to algebraically, solving this or simplifying, evaluating, I should say, this limit, then teach me how, right? To do that and to Dougie. I never learned the Dougie. Teach me how to Dougie. You would have come up with 35/4. Okay. The power rule, very powerful. Happy National Coffee Day, everyone. And on this day in 54, Willie Mays made his over-the-shoulder basket catch at the Polo Fields in Game 1 of the World Series. 460-foot shot, right? That would have been an in-the-park home run had he not done that. Say, hey, kid. Happy birthday, Kevin Durant, who's 33 years young. Hook 'em horns. And happy birthday, Jerry Lee Lewis, who's already 86 today. He's known for two things. Number one, playing the piano standing up when he played songs like Goodness Gracious, Great Balls of Fire, and for marrying his 13-year-old first cousin. Yeah. All right. The word of the day is callow. Callow means youthful, immature, inexperienced, or literally without feathers. I'll use it in a sentence for you. Jerry Lee Lewis married his callow first cousin. Yeah. He was older than 13. Yeah. I'm not that well versed in Jerry Lee Lewis ancestral trivia. But you could look it up. How old is he when he married his 13-year-old cousin? Okay. There you go. All right. So real quickly, let's talk about the test tomorrow, and then we'll jump back into the notes. The worksheet for 2.1, of course, will be due. We're going to come back and do 2.2 later, so you don't need to worry about that. The worksheet for 2.3 is not going to be due tomorrow, because we're not going to finish 2.3 notes in time for tomorrow's test, okay? But you do want to make sure that you do enough of the worksheet so that you understand the power rule. And a couple other things that we're going to finish up today. But if you go to Calculus Maximus or to the Canvas website, to the old tests, click on old tests, and over here you'll see there's not specifically a test that takes us from 1.1 through 2.3. Okay, there's not. So you have lots of them that cover all of chapter 1, 1.1 through 1.5. And then you have a couple of them that go from 2.1 to 2.3, and then some in between there. So, you'll just have to practice, I would say if you were able to do all of these tests from 1.1 to 1.5, 2.10 to 2015, and all of the tests from 2.1 to 2.3, 15, 7, then you should do well tomorrow. Okay. But anything short of that, of course, you could do very well as well. It's just up to you. Every person's different. So, what's that? Yeah, it's wild. Yeah, they called him the killer. All right. So that's that, and it'll be again. We can use advisory to train, and we'll take a lunch to train. So you have quite a bit of time to get questions answered before the test. But it shouldn't be like, oh my gosh, how do you do this, right? It should just be like, I worked this 32 times last night, and I'm still off by a negative. Where did I go wrong? I'm like, let me help you. And then we'll test during C lunch and D lunch. So it'll be an hour-long test. Okay. So questions about that or the warm-up? All right. Example 3. Let's pick back up then with the power rule. because now that we can easily and quickly find derivatives, we don't have to like invest all that time and energy, you know, setting up the limit and evaluating it. We can get to the derivative a lot more quickly. That frees us up to do other things, like use the derivative, okay? So that's what we're doing here on example 3. If f of x is that, find each of the following. F prime is -1, f prime is 0, and the x coordinate where the slope is 128. Okay, so here's the deal. Before I can find f prime of a number, like -1, unless I'm using alternate form or modified form, I need to find f prime of x first. So just like we did on the warm-up, I need to find f prime of x, and then I can find f prime of c. Okay? So let's do that. I'm going to rewrite the function, f of x equals, but I'm going to write it as 1/2 x to the 4th. Because now that's in ax to the nth format. Yeah? Yeah. So dividing by 2 is the same as multiplying by 1/2. So here we go. F prime of x, that's the derivative of the left, notation. And now I don't need to set up the limit definition. Thank goodness, because x plus h to the 4th power, I only do that like on Friday nights when everyone's out having a good time and I'm home myself and the phone's not ringing. Yeah. And I only do that because that helps the time pass quickly. Multiply and subtract. 4 times 1/2 is 2. 4 minus 1 is 3. Kaboom! Yeah, I'll be right there. It's Friday. Yeah, I'll be right there. Let me just take the derivative of this real quick. Boom, done. I'm with you. All right. Now, notice it's kind of interesting, right? The derivative of a quartic is a cubic. Huh. The derivative of a cubic would be a quadratic. The derivative of a quadratic would be linear. Interesting. Well, that makes sense. The power rule, right? The derivative is always n minus 1, 1 degree smaller. Cool. All right, let's try f prime of -1 then. F prime of, I plug a -1 on the left, and I plug a -1 in on the right. Free response, we're done right there, right? I'm not simplifying that. But yes, I am for multiple choice. That gives us -2. So what does that tell us? That tells us that on the graph of x to the 4th halves, whatever it looks like, the function is doing what? Increasing or decreasing there? Should be decreasing, right? It's decreasing at an instantaneous rate of down to right 1 at that instantaneous moment. If you want to graph 1/2 x to the 4th, let's quickly do that. It's kind of like a parent function. Your parent function is x to the 4th, which looks a lot like the parabola, except it's saggier between -1 and 1 and steeper outside of that. So for all intents and purposes, it looks kind of like a parabola, kind of flattened like that. Oh, is advisory over? Cool, yeah. All right, so here would be essentially possibly where -1 is. What we just found is this right here. We know the slope of that line is what? -2. Fancy, right? Fancy. Okay, I'm going to go ahead and label that m equals -2. What is f prime of 0? Well, based upon our accurate graph, we would anticipate it to be what? 0 is kind of like our vertex, and what type of tangent line do we have there? Horizontal tangent line, and what's the slope of a horizontal line? 0. Yeah, so let's see if it works out. F prime is 0. If I plug a 0 in, I'm going to work left to right here. I'm going to get 2 times 0 cubed, and bless you. Once you work left to right, you need the equal sign, and then you work straight down. Don't keep working left to right. You should really have no more than 2 terms left to right. Don't keep going. Once you have that second term with the equal sign, now you work straight down. 2 times 0, which is 0. Of course, you don't need to show that many steps either. But there you go. The slope is 0, just as we anticipated. Now, what you're going to see in the future is, instead of just trying to plug in random values of x and see where the derivative is 0, one of the powerful applications of calculus is finding the x values where the slope is 0, because those are possibly vertices, or in general, local max and local mins. So in the future, we're going to be setting the derivative equal to 0 and solving. Okay. Speaking of doing that, let's find the x coordinate where the slope is 128. Now let's try to draw that first. If I come out here and I try to draw a slope of 128, that's going to be possibly right there. Yeah, that's pretty steep. And I don't know what the x value is, but I know it's going to be something to the right of 1, yes? This graph has y-axis symmetry, so I would expect the slope at 1 to be positive 2. So I know it's going to be something bigger than 1. Well, let's see. I'm going to say f prime of x. Instead of plugging in for x, I'm going to set it equal to 128. Well, that's going to be 2x cubed equals 128. By the way, in the future, like you're going to, on a free response, you're going to get a check for doing that. You really only need to show one of these to get the check. And if you're only going to show one of them and you're given the equation, it's probably going to be the second one. But you're welcome to show both. You always need to show what it is you're plugging in, right? Like f prime of -1 versus f prime of x. And then you always need to show the equation you're solving. All right, so now we'll solve algebraically. Divide through by 2. Half of 128 is 64. And now I take the cube root of both sides, which is the cube root of 64. On a free response, are we done? Yeah. On a multiple choice, it's probably not going to be an answer because is 64 a perfect cube? Yeah, I think it is. Yeah, it's okay. I think it is. Yeah, it's 4. Yeah. 4 times 4 is 16. 16 times 4 is 64. So there you go. All right. So nice application. Now let's do something else since we're right here. Hey, Mac, how's it going? Oh, fantastic. These are for people when they get in trouble to go to the office?
Essentially.
Okay. Oh, and bathroom.
They didn't tell anyone about it, though. They sent no emails or anything.
Well, Mac, you are more than capable of delivering that message, and I appreciate it.
They're making all the.
Yeah.
Yeah.
I can still make you carry my jingle bell while you wear the path.
Make us carry it if you want.
You want to carry it. Jingle all the way, right, Mac? Yeah. Okay. We will. All right. Let's go ahead and do this. Let's go ahead and write the equation of one of these two lines. Do you want to write the equation of the red line or the brown line? Red line? I was hoping you would say brown, but that's okay. No, let's do the red line. Beefy brown. I know. Is everyone okay with beefy brown? Beefy brown. All right. What do we need for the equation of a line, Woolsey? Woolsey, what do we need for the equation of a line? Yeah, very good. We need to use Taylor's form, okay? We need a point, which is x sub 1, y sub 1. I'm not going to call you Woolsey anymore because I don't want to annoy you or aggravate you. And we need a slope, right? Slope. All right, and then once we have those two, then we're going to drop it into Taylor form. Taylor form is just something you got to flat out memorize, right? It's y equals the y value, y sub 1, plus the slope times x minus the x value. And I showed you where it came from. It didn't come from France. It came from the equation for slope. All right, so let's gather our information. I like to have all my ingredients right in front of me in those little pre-mixed bowls, like on the cooking shows. Like when I'm making cereal, I'll put cereal in a bowl, dry cereal in a bowl, and then I'll put the milk I need in another bowl. And then I'll put the cereal that's dry in the bowl. I'll put it into a bowl, another bowl, and then I'll empty the milk from the bowl into that bowl.
You put cereal before milk?
Oh, yeah, yeah. And I always measure it out in a bowl. I like to have all my, like when I'm making toast, I'll have like the bread on one side in front of me and the toaster on the other before I combine the ingredient. I like to have all my ingredients in front of me. All right. So my point is going to be what? Well, I know that the x value is 4. I just found that, didn't I? Okay, I know that the x value is 4. The y value is going to be f of 4. Okay? The slope, I know what it is, but in general, it's going to be the derivative at that x value. So if you don't have the point and the slope, really all you need is an x value and a function. Because you can find the y value by plugging it into the function and getting the y value, and you can find the slope by finding the derivative and plugging it in. So let's go ahead and make it specific. This is the 0.4 comma. I don't know the y value yet. I do need to plug it in. So f of 4, do I plug that into the derivative or do I plug it into my original equation? Original, right? That's the y value equation. So I get 4 to the 4th over 2. Yikes. What is 4 to the 4th equal to? It's 64 times 4, right? 16, carry the 1, 256. It's 16 squared. Yeah. Yeah, so this is 256. And then, of course, we know the slope there is what? 128. That was specified. So here we go. So the tangent, so say, so the tangent line equation is y equals the y value of 256 plus the slope of 128. Como? What? Oh, the 250. Oh, yeah. It's divided by 2. Sorry. Yeah. Yeah, my bad. Thank you. 256 divided by 2. Yikes. What is that going to equal? 128. Very good. Y'all are on top of things here. I'm going to blame that on tunnel vision. Okay. When you have an iPad, you get tunnel vision, right? Like I'm right here in the zone and I forget what I'm doing. Thank you, guys. Thank you. Y equals 128. The y value plus the slope 4. No. Plus the slope 128. Okay. Times x minus 4. So even with the ingredients right in front of me, I can still mess up, right? Like I pour, like I put the milk into the bowl that measured my dry ingredients instead of putting the dry ingredients into another bowl before I pour the milk. And guess what line comes for absolutely free at no additional cost? The normal line equation is, well, let's get the ingredients in front of us. The point for the normal line is the same thing, 4, 128. But what's the slope of the normal line? We already talked about it once this year. Once is enough, right? The normal line is perpendicular to the tangent line. So it's the opposite reciprocal, negative 1 over 128. Yeah, opposite reciprocal. If you were only asked for the normal line, you would still find the derivative first, which is the tangent line slope, and then you take the opposite reciprocal of it. So the normal line equation is y equals the same y value, 128, plus the slope, which ends up being minus 1 over 128 times x minus 4. And in Taylor form, the only noticeable difference in the two forms is the slope. But bear in mind that they do, in fact, have different y-intercepts, right? We talked about that as well. If you were to distribute the 128 or negative 128, 1/128ths, you would get a different constant, okay? So the normal line, if you're interested in drawing it, the normal line would look something like this. It would come in here perpendicular. And you could tell that since the tangent line is very steep, the normal line is very shallow, right? Okay, so just add a little bit extra to that. All right, go ahead and do example 4A and B then on your own. Now that we've done that, I'm going to pause the recording and come back to it. All right, so we got our function. F of x is 3x squared. Question A, find the equation of a tangent line. So I went ahead and drew f of x equals 3x squared down here in blue, and the equation of the tangent line at x equals -2. So that's the green line, yeah? The green line is the tangent line. I'm going to call the tangent line t of x, and I'm going to call the normal line, which would be perpendicular to it, I'm going to call it n of x. Just so we can distinguish, you know, among the three functions now that we have. T, tangent, and normal, and f function. Okay, so I need to collect my ingredients, right? I need a point and a slope at -2. Well, I have neither, but I do have an x value and I do have a function, which is probably all I'm going to need. Let's find the point first. The point is going to be -2 comma f of -2, which when we plug in f of -2, let's see, -2 squared is 4, 4 times 3 is 12. So there's the point -2, 12. I'm going to come down here and label it. It's the point of tangency. It's also the point of normalcy, right? Which we're almost there in terms of the pandemic, right? We're almost back to the point of normalcy. Normalcy is actually a made-up word that has made its way into the common vernacular. The correct term is normality, but hey, whatever. That's what happens when it was one of the presidents, right? Tippecanoe and Tyler too. One of them called for a return to normalcy, and they made up the word, and it kind of stuck. But anyway, the proper word is normality. But we have the point of normalcy, which is that point, and the point of tangency. Those are both used in the right context. Was it Harding? I thought it was Harding, yeah.
It was actually during the last, or not last, the Spanish flu.
Oh, there you go. Okay. So, yeah, there you go. All right, now we need to find the slope at a point, right? We need to find the slope at that point. Stay with me here. Slope at a point. Slope at a point. What's another name for us now for slope at a point? Slope of the tangent line at that point, which is the big D not Dallas derivative at that point. Yeah. So that's okay. So the slope is going to be f prime of -2. But before I can find f prime of -2, I need to find f prime of x. So here we go. F prime of x is power rule, right? It's in ax to the n format. So multiply, subtract, you get 6x to the first. Oh, that's nice. And now f prime of -2. You show it on both sides, and you get -12. All right, cool. So there's your slope. Is that a reasonable slope for the green guy here? Yeah, it's decreasing. And so now here's the equation. So now you don't have to say so the equation of the tangent line is, because on part A, that's the only thing they're asking for. So I'm just going to go ahead and say y equals the y value of 12 plus the slope, which becomes -12, times x minus the x value, which is x plus 2. Okay? And now if you want to give it a name, t of x, Texas of x. 12 minus 12, x plus 2. Remember that in Taylor form, the only part of the formula that's negative is the x minus. Some people want to do the y value minus the slope. The slope is only negative here. That's why that term is minus. All right, and now for the normal line, you don't even really need to show anything. I don't need to have my ingredients in front of me. It's pretty easy. N of x for normal line would be the same y value of 12, but what's the perpendicular slope of -12? Positive 1 over 12. Yeah, the opposite reciprocal. And it's still x minus -2 or x plus 2. Okay, so pretty much comes for free. All right, so those are the two equations. I guess I should maybe color code it. This is the equation of the red line, and this is the equation of what I have drawn as the green line. Now, this is what makes this a good free response question. Although if you look at the practice test, I kind of like the free response that's up there with the gigantic piecewise function where I can pick pieces there now to force it to not just be continuous, but differentiable, and where I can ask an IVT question. So anyway, but this itself would make a dandy of a free response question on like or on a regular AP exam. Find the points where the normal line intersects the graph of 3x squared. Well, this is where if you hadn't done so already, it would be helpful to draw a picture, but it's still not required. So there's two places where the normal line in red cross the blue function in blue, right? Here at the point 212, we already know that point. And there's another one over here. Now, by symmetry, I know that the x value has to be what in comparison to positive 2? Is it bigger than 2 or smaller than 2, that other point? Should be bigger than 2, right? Because of the symmetry of the parabola, and the red line goes uphill, I know it's going to be to the right of 2, and the y value is going to be to the above 12. I just don't know what it is. So how can I find that other point of intersection? Well, go back to algebra. If you want to find the point of intersection of two equations, or where the two graphs intersect, what can we do with the two equations? Set them equal to each other. Yeah. So that's what I'm going to do. I'm going to say n of x is going to equal f of x. That's the solution I'm going to solve. So with Taylor form, they're already solved for essentially y. This is like setting the two y values equal to each other. So it's like substitution. One y equals another y. So I get 12 plus 1/12 of x plus 2 has to equal 3x squared. That would earn a check. Well, you already earned the check up here. You can set them equal by name, but then you're going to need to set their expressions equal to each other because you have to manipulate it, right? If this were a calculator question, you would just get it all on one side, set it equal to 0, and find the point of intersection. There should be two of them. But without a calculator, we got a little bit of algebra left on the bone. Thank goodness. All right, so here's what we need to decide. Do you want to embrace the fraction or eradicate it? We're going to have 1/12 all over the place. Good. Let's eradicate it. I'm going to multiply this side and this side by the LCM of my miniature denominator. This is like the equation version of Lickum over Lickum. Lickum over Lickum works when you have an expression and you can't change the value. But if you have a conditional equation and you're trying to solve, you can multiply both sides by Lickum. Okay? Now, Ethan, you work it with the 1/12 intact, and we'll work it without the 1/12, and we should get the same answers. But we're going to finish before you. That's okay. I like your idea of embracing the fractions. Now I'm going to distribute on this side. 12 times 12 is 144. And now be careful. When you distribute the 12 to the second term, you have 12 times 1/12 times x plus 2. You don't distribute the 12 to both of those factors. You only multiply all three of them together. Well, guess what 12 times 1/12 is? Positive 1 times the x plus 2. Now, really, do I need to even put the 1 in the parentheses around x plus 2? No, because there's nothing to distribute. But I'm going to put them there just as an inventory line, because had that been like a -1, you would need to distribute the negative. Had it been like a +3, you would have need to distribute the +3. And that's a place where a lot of students can make a careless mistake. Now, on the right-hand side, again, we don't distribute the 12 to both factors. We just multiply any two together, and we get 36x squared. All right, so if I combine like terms, right, I distribute the 1. Oh, that's good. I'm going to have 144 plus 2, which is 146, plus x equals 36x squared. Well, hello, quadratic trinomial. You see that? The terms are all over the place, and they're not written in any kind of order, but when you have a squared term and a non-squared term and a constant, you got to get everything on one side, set it equal to 0, and F it, right? Now, I don't like negative leading coefficients, so I'm going to bring these two rascals over to the right-hand side. So I have a 0 equals 36x squared minus x minus 146. Okay, now the fun part. I'm looking for combination of factors of 36 and 146, combinations of those factors that add up without a calculator, that add up to -1. Criminy. There's going to be a whole mess load of possibilities, aren't there? Like, what are the factors of 36? Well, there's probably only one, right? 1 and 36, or 36 and 1, 2 and 18, 3 and 12. Holy mo, 4 and 9. Oh my goodness, Jiminy Crickets. Thank you. Thank you. We already know one of the factors because we already know one of the solutions, don't we? There you go. Don't invent the wheel every time you need to get in a car and drive somewhere, right? Hey, I need to go let my dogs out at lunch. Yeah. Well, before I can get in the car and drive home, I need to invent the wheel. No, the wheel's already invented. I paid for the truck, just get in and drive, let those dogs out. Now, if I could teach them to pee outside in the rain, that'd be better. We already know that x equals -2 is a root of that equation. And therefore, what's the corresponding factor? X plus 2. If a is a root, x minus a is a factor. If -2 is a solution, x minus -2 or x plus 2 is a factor. So I know one of the factors is x plus 2. That allows you to force the other factor, right? If I know that I have an x, this needs to multiply to get a 36x squared, so it has to be a 36x, yeah. And if I know that I have a 2 here, then multiplying that by the last one needs to give me a -146. It has to be a -73. And now we quickly check the inner and outer. The inner is going to be +72. The outer is -73. -73 plus 72, orale, is -1. And therefore, we get x equals -2, or if we solve that in our head, x equals 73/36, right? If you need to physically set them both equal to 0 and solve, so you don't make an algebraic mistake in your head, go ahead and do that. So now I'm going to say the 2 points. The 2 points, I'll finish this up and then we'll go. It's -2, 12 and 73/36, 3 times 73/36 squared. I'm going to leave it like that. All right? You don't want to leave it as f of 73/36 on a free response because that's not evaluated. But if you plug it into the function and not simplify, 3x squared, there it is. Now you're good, okay? All right. Y'all have a good lunch. I hope to make it back by the start of C lunch, but if I'm not, just wait longer, okay?